All right, guys. So continuing with geometry, you have just recently discussed in class 10.2, which is all about triangles. And again, as you know, you've seen in class, and as of what I've told you, is that geometry keeps building upon itself. So in 10.3, we're going to talk a couple more shapes, like quadrilateral specifically, and then any other shape that's beyond that. Again, all these shapes, even quadrilaterals, they are made up of triangles. That's where we start getting all the properties about all these other shapes from, is because they are made up of triangles. And when you were in high school, even though we're not doing it here, you learned about how to prove triangles are congruent. And because you know that triangles are congruent, you learned some different things about them. One of them was called CPCTC. That's CPCTC, which means corresponding parts of congruent triangles are congruent. Again, it's been a while since you talked about that, but it's because of that CPCTC idea, corresponding parts of congruent triangles are congruent, that we get properties for quadrilaterals. Again, like I said, all these different shapes that we now have in our geometry, they come and they extend from ideas about triangles and parallel lines. So let's start talking about quadrilaterals, and I'll show you what I mean by that. So the first thing is, what is the basic definition of a quadrilateral? All that it takes to be a quadrilateral is you need 4 sides. That's it. That's what it takes to be a quadrilateral, because that's what the quad means. It means 4, and lateral just means sides. Okay? So all it takes to be a quadrilateral, 4 sides. And it has to be closed, meaning that I can't have any openings. So I can't say, just because this has 4 sides, that that's a quadrilateral. That's not, because it is open. This little piece that's right in here is what we call open. Just like triangles, the idea behind a triangle is all it takes to be a triangle is that you have 3 sides and 3 angles, but it also has to be closed, okay? Meaning that all the sides have to connect at their endpoints. That's what it means to be closed, okay? So 4-sided closed shape is a quadrilateral. And then from there, you start getting different types of quadrilaterals, special cases of quadrilaterals. But again, all these special cases and all their properties of these quadrilaterals we're about to talk about extend from the fact that these quadrilaterals are made up of 2 triangles. And because these 2 triangles share a relationship, for instance, they're congruent to each other, they're the same shape, we get special properties about this. So I'm going to highlight some basic properties about these quadrilaterals that we're going to run into. So the first special quadrilateral we're going to talk about is the parallelogram. It is the parallelogram. So this is the symbol for a parallelogram. Looks like a drunken rectangle. That's what most people call the parallelogram. It's your drunken rectangle because it is kind of like a rectangle that is slanted. Okay? I'll explain some of these symbols here in just a second. Okay? But what it means to be a parallelogram is that it is a quadrilateral. It has 4 sides. And what's special about the quadrilateral is that it has 2 sets of opposite sides that are parallel. Remember this 11 right here? That is the symbol for parallel. Okay? So, if you look down here at our figure, the basis of a parallelogram, again, is that it's 4 sides and opposite sides are parallel. That's what these little arrows right here means. Usually, though, they're filled in triangles. So these 2 arrows, since they match in symbols, means that side AB is parallel to side CD. And then it says it has 2 sets of opposite sides. So these little sets of arrows right here that match mean that these 2 sides, AC and BD, are parallel to each other. Okay? So That's the basis of a parallelogram. It is a quadrilateral that has two sets, 1, 2, of opposite sides that are parallel. So some other things that we get, some other properties of the parallelogram that we get, and again, this is all based off of congruent triangles, is that you also find that those opposite sides that are parallel are also congruent to each other, meaning that they're the same length. That's what you see these little dashes for. This little dash right there means congruent. And this little dash down here that matches it means that these two sides, AB and CD, are congruent, hence why they're both red, because they're congruent and they're parallel. And then you can see this over here. You see two lines right there, and you see two lines right there. Those two lines, again, just mean sides are congruent. So side CA and side DB are congruent to each other, hence why they're both the same color green. And then the last piece, but not least, is because of these congruent triangles, is you get two sets of opposite angles congruent. So for instance, angle A, that's right here, is congruent to angle D that's down here. Those two angles are the same. And again, that stems from the fact that you actually have two triangles. Here I'll kind of highlight those triangles. These two triangles are actually congruent, meaning that they are the same. Okay? And then we also get the fact that these two angles are also the same. Angle B is congruent to angle C. That's what we mean by opposite angles are congruent, the angles that are across from each other. Okay? So those are some special things about parallelograms that we know. And again, there's a whole heck of a lot more, but we don't need to know that because we're just being superficial with all these geometries, like I told you in class on Monday. We're just being superficial. We just want to know the basics. So with the parallelogram, some things that you know. You have two sets of opposite sides that are parallel. Those same set of opposite sides are also congruent. And then you have two sets of opposite angles that are congruent. Okay? So let's talk about our next shape. And the next three shapes that we actually talk about, they're going to be relatives of the parallelogram. So everything that you see right here that I starred, all of these next three shapes will share those same features. Two sets of opposite sides will be parallel. Two sets of opposite sides will be congruent. Two sets of opposite angles will be congruent. So the next one I want to talk about is the rectangle. Okay? So what's special about the rectangle, and the only thing that I want you to remember, is that it comes with 4 right angles. Okay? Or in other words, 4 congruent angles, because they're all right angles. So a rectangle, again, it is a parallelogram, so you can see all that stuff. You can see the opposite sides are parallel. That same symbols that you saw a moment ago. So there's one set of opposite sides parallel. Here's the other set of opposite sides parallel. You can see that they share the opposite sides are congruent. This side is congruent to that side. This side right here is congruent to that side. They are opposite. They also have that opposite angles are congruent, but more importantly, actually all 4 of those angles are congruent because you have 4 right angles. So again, a rectangle is a parallelogram, but it is special because it has 4 congruent angles because they are all right angles. That's why you see this, come back. That's why you see this little square right here in the corner, and this little square that's right here in this corner. That means right angle. Square down here, that's a right angle. Square down here, that's a right angle. Okay? Which means that they're all congruent to each other because they're all 90 degrees. So those are what I want you to know about the rectangle. That's it, nothing else. Don't worry about all this mess that's inside here. That all happens, again, because of congruent triangles. But again, we're surface level on this, nothing crazy. So the rectangle, again, has these 3 stars because it's a parallelogram, but it gets some new information because it has 4 congruent angles, because they are all right angles. Okay? The next one after this is the rhombus. Again, a rhombus is a parallelogram, so it shares all that same information. So again, you see that right here. These two sides are opposite sides, and they're parallel to each other. These two sides are opposite sides, so they are parallel to each other. Again, that's what it takes to be a parallelogram. Opposite sides are parallel. You also see that this side is opposite this side, and it's congruent. You see that this side is opposite this side, and it is congruent. Again, that's because of the parallelogram. Opposite sides are congruent. But in the rhombus, where the rectangle had 4 congruent angles, the rhombus, if you look at all these symbols, these congruent symbols, this guy and this one right there and that one right there and that one right there, notice they're all the same symbols, because in the rhombus, what is special about it is that all sides are congruent. So the rectangle had all angles congruent. The rhombus has all sides congruent. Okay? And then the last piece of the rhombus, because it's a parallelogram, you have those opposite angles that are congruent. So again, you see all the properties of the parallelogram in there, just one new special property about a parallelogram. When all sides are congruent on a parallelogram, you have a rhombus. When all angles are congruent on a parallelogram, you have a rectangle. And then last but not least, I call this kind of the incestual love child of the family of parallelograms, because if we take a parallelogram, a rectangle, and a rhombus, and they had a love child, that would be the square. The square is a parallelogram with all sides congruent, comes from the rhombus. All angles congruent, which comes from the rectangle. And then it's a parallelogram. So you take everything that we just talked about, opposite sides parallel. You can see that in this picture. Opposite sides are congruent. In fact, all sides are congruent because it's a rhombus. All angles congruent, because that comes from the rectangle. You put all that together, that's the square. Again, there's a lot of extra information on the inside, but we don't worry about that. So that's where the square roughly comes from. It is the ancestral love child of the parallelogram, the rectangle, and the rhombus. Okay? So those are the basics that I need you to know about this. Those are the basics of rectangles, rhombus, and square, and the parallelogram that I need you to know. Now, there are 2 other special shapes that we can talk about with quadrilaterals. These are not parallelograms by any means. Okay? So one of our shapes that we can talk about is the trapezoid. What it takes to be a trapezoid is that you have one set of opposite sides parallel. Okay? Notice it's a quadrilateral, so it's got 4 sides, but what's special about this quadrilateral is you have one set of opposite sides parallel, which you can see there. I've marked it for you. Okay? Only one set of opposite sides parallel. That's what makes a trapezoid. That's it. That's all there is. There are other properties to the trapezoid, but I don't want to go into that. Okay? There are other properties of a trapezoid, but again, we're just keeping this superficial. Okay? On the surface level. So one set of opposite sides parallel. There is another type of trapezoid that maybe you've talked about it, maybe you haven't. It's called the isosceles trapezoid. If you want to look it up, you can. What the isosceles trapezoid is, just real quick, you have one set of opposite sides parallel, and these lines that are right here, the ones that would actually intersect each other, they're called the legs, and they would have been congruent to each other to be an isosceles trapezoid. But again, we don't have to know about that. But there is one that exists, because sometimes you'll see that in the material, just so you know. So an isosceles trapezoid would be one set of opposite sides parallel, and the legs would be congruent. Okay? The sides that are parallel to each other, we call those the bases. The sides that are not parallel to each other, we call those the legs, just so you know. Because that word bases will come in handy for us later on. Then the last special kind of quadrilateral we have is what we call a kite. Okay? Again, it is a quadrilateral, but what this one has that's special is it has two sets of consecutive sides that are congruent. Consecutive sides means that these are two sides that actually touch. And so when you look at the picture, hopefully your common sense will kick in and you know which are the two consecutive sides. Okay? Generally, in a kite, you have two sides that are really short that are going to be congruent to each other, and two sides that are really long that will be congruent to each other. And here's what the picture looks like. Again, there are other properties to this, okay? But we only just need the superficial one. So two sets of consecutive sides congruent. And in fact, our book doesn't even really talk about kites, but I wanted to show them to you because they are, kites are a special form of quadrilateral, okay? And it's because they have two sets of consecutive sides that are congruent. All right, so what's going to happen in your assignment, because I believe I move on to the next information on the next picture. Yeah, so going back to quadrilaterals, what's going to happen in your assignment is this. Okay, that's my email. You don't want that. Oh, I closed it out. So let me jump into this. Let's go into your book. Okay. Sorry, I had the textbook up, then it closed it all out. So, my bad. So let's open our book. Let's go into section 10.3, and I'll show you what they want you to do with this information. Again, you just kind of need to know those properties, okay? So we're going down to chapter 10, section 3. Man, I didn't want to do that. So there's the beginning of chapter 10. I want to jump into 10.3. So open it up, and going into 10.3 from the backside of 4. So up here, it says use these quadrilaterals to solve 5 through 10. So in other words, what it's asking you is, they want to know which picture up here, this is your square, this is your rhombus, this is your trapezoid, your rectangle, your parallelogram. So which one of these have these qualities? Okay, so question 5 says which quadrilateral or quadrilaterals, because it could be more than one, which quadrilaterals have opposite sides that are parallel? Okay, so up here you could talk about the square because it is a parallelogram, and parallelograms have opposite sides that are parallel. You could talk about the rhombus because it is a parallelogram. Any shape up there that is a parallelogram has this. Opposite sides are parallel. Okay? The only one you wouldn't talk about in here would be the trapezoid because it only has one set of opposite sides parallel. Okay? So another question of these, which of these quadrilaterals have sides of equal length that meet at a vertex? So in other words, what it's saying is they have 4 congruent sides. So who is that up here? Well, if you look at the picture, it's kind of marked for you. Oh, that's the square, and that's the rhombus. So you get what they're doing. They're just basically giving you these shapes, and they want to know which ones have these properties that we just talked about. Okay? So like number 7, which of these quadrilaterals have right angles? Well, that would be the square and the rectangle. So that's what you're doing with quadrilaterals. Again, very, very surface-based. Know those basic properties. Who has opposite sides parallel? Both sets. Who has both sets of opposite sides congruent? Who has opposite angles that are congruent? Both sets. Who has all 4 sides congruent? Who has all 4 angles congruent? Who has one set of opposite sides that are parallel? Okay? Which figures up there are parallelograms? Different things like that. If you can answer those questions, then you know the properties that you need to know. All right, continuing on. So again, from there, we start expanding into all polygons. And again, all polygons are just made up of triangles, a 3-sided figure. So you've already seen that Quadrilaterals are just made up of two triangles. Triangles, well, they're made up of one triangle because that's all that makes. If you make a pentagon, it's actually made up of three triangles. Let me show you what that looks like real quick. I'll draw up a pentagon. So here's a pentagon. It's really made up of three triangles. You can see them. 1, 2, and 3. Three triangles make a pentagon. If I had a hexagon, which is a 6-sided figure, it would be made up of 4 triangles, and so on and so forth. Okay, so let me get rid of this real quick. So what we're doing on this screen real quick is, since we're going to talk about other polynomials, you need to know their names. So that's what you're going to see here. If you have a 3-sided figure, what's the name of it? It's a triangle. If you have a 4-sided figure, what's the name of it? We already know this. It is a quadrilateral. Now, some of the other ones that you may or may not remember. If you have a 5-sided figure, I just said that a moment ago, that's a pentagon. The 6-sided figure, I said that a moment ago, it's a hexagon. But what about 7, 8, 9, 10, 12, and what if we just have n number of sides? Like a polygon that has 11 sides, 13 sides, 14 sides, 30 sides, 100 sides. What do we call those? Okay? So a 7-sided polygon, there are actually 2 names for this. You get to pick. Some books go with septagon. Other books go with heptagon. Okay? So you choose which one you want to do. Septagon or heptagon. This kind of sounds like transformer names. Okay? 8-sided figure, hopefully you remember what that is. Octagon. 9-sided figure is the nonagon. 10-sided figure, decagon. So hopefully you remember 3 through 10 back from when you're in high school or whenever you talked about shapes. I throw 12 up here. Technically, I don't have to talk about its name, but I like the name of 12. I like to say it. It's kind of fun. The 12-sided figure is what we call a dodecagon. That's just fun to say. Dodecagon. I love it. Okay? Now, any figure that is not any of the numbers up above are what I call an n-sided figure. How do we name n figures? Super simple. We call those n-gon. Okay? So if I have an 11-sided figure, I would call it 11-gon. I just put the number in for n. If I had a 23-sided figure, I call it 23-gon. If I had a 17-sided figure, 17-gon. It's that easy. Just take the number and slap it in. Everybody else, though, I want you to know the name for. No cheating and saying 7-gon, 8-gon, although that's not incorrect. But I do want you to know those names because they will talk about those names in problems, and you need to know which ones you're dealing with. Okay? So that's how we name polygons. Pretty straightforward, nothing crazy. And then what they want you to know about polygons is they want you to know about the sum of all the interior angles. Okay? So I want to talk about these in terms of formulas because in the end, I want you to be able to generate, if I give you any number of sides here, how do I find the sum, the addition of all the inside angles? How do I know what they all add up to? So up here, I want you to kind of see a pattern, and that's what we're going to establish. So if I have a triangle, so the number of sides, 3 is a triangle. So if I have a triangle, how many triangles make it up? Well, just one. Remember, I've kind of showed you those pictures. There's only one triangle that makes a triangle because it is a triangle. And how much do all the angles inside a triangle add up to? We talked about that in 10.1, 180 degrees. Okay? So if we move to the 4-sided figure, which is a quadrilateral, how many triangles make it up? Again, we just talked about that at the beginning of this lesson. It is made up of 2 triangles. And if each triangle adds to 180 degrees, that means all the angles inside a quadrilateral must add to 360 degrees. because one triangle is 180 degrees, another triangle is 180 degrees. So 180 plus 180 is 360. If I had a pentagon, 5 sides, I just showed you how many triangles it have. And how many was that? Yeah, you got it. 3. So since it's made up of 3 triangles, each one adds up to 180. So that's 180 plus 180 plus 180, which gives us 540 degrees. 540 degrees. Because all you do is basically take 360 plus 180. 8 plus 6 is 14. Carry the 1. 1 plus 3 plus 1 is 5. Okay? Well, if a triangle has 1 triangle, a quadrilateral is made up of 2 triangles, a pentagon is made up of 3 triangles. How many triangles make up a hexagon? 4. And again, all that you're going to do there is take 180 plus 180 plus 180 plus 180 plus 180. Or take the 540 and add 180 to it. And that will give you 720 degrees. Hopefully by now you have seen the pattern that is going on. So if I have an n-sided figure, what's the relationship between the number of sides and the number of triangles? Hopefully you saw that it's, that it is n minus 2. Because if you look up here, what's 3 minus 2? That's 1. What's 4 minus 2? That's 2. 5 minus 2 is 3. 6 minus 2 is 4. So if you have an n-sided figure, all you got to do is subtract 2 from that number, and that tells you how many triangles makes it up. And then if you want to get the end result, even though we are adding 180 4 times, really it's just taking 180 times 4. Even though we added 180 3 times, to get to this answer, really it's just taking 180 times 3. Same thing on up above. So if I have an n-sided figure and I want to know what do all the angles inside add up to, all I'm going to do is take the number of triangles I have, which is n minus 2, and multiply that by 180 degrees. That's the formula that will tell you how much all the inside angles of any polygon add up to. N minus 2 times 180. It's a nice little pattern. Again, some dead white man figured that out. We got a lot of times on our hands, if you haven't told, as dead white men. So, in your assignment, this is what they're going to do to you. They're going to say, hey, right over here, find the sum of the measures of an angle of a 6-sided polygon. Right there, they told you how many sides it has. So take 6 minus 2 and multiply that by 180, which we already gave you the answer to that. It's 720 degrees. Or, hey, find the sum of the measure of the angles of a heptagon. Hepta is 7. Take 7 minus 2 and multiply that by 180. You got your answer. See if there's any other things that they do on here. So there you go. And that right there ends our discovery and discussion of shapes. So now the rest of this stuff that you're going to see in 10.3, 10.4, and 10.5 is all about perimeter, area, and volume. Oh, here I got an example. A 10-sided polygon. What is the sum of all the interior angles? So all you're going to do is take 10 minus 2 times 180. And that will give you your answer. And I don't know that answer off the top of my head, so let's just go 10 minus 2 times 180. So all the angles inside a decagon will add up to 1,440 degrees. And there you go. Okay, I don't think I have another example after that. Nope. So again, like I was saying just a moment ago, everything now that we talk about is all about perimeter, area, and volume. Plug and chug type ideas. So we have covered all the geometry basics. Now we talk about, again, perimeter, area, and volume. So the rest of 10.3 is all about perimeter. So how do we find the perimeter of a shape? Give you a moment to think. Yeah. So to find the perimeter of a shape, all you're going to do is add up all of the side lengths around the outside. Okay? Think about another way that I think about perimeter so that I don't ever forget it. Think about like if you're the guard of a jail and you say to your partner, hey, I'm going to go check the perimeter. That means you're walking the outside fence of the jail or the prison. When you say you are walking the perimeter, you are doing exactly that. You're walking the outside of the shape of the object. Okay? So all we're doing with perimeter is adding numbers together. So here's my shape. Go ahead and try and find the perimeter for this. I'll give you a moment to think. Pause the video. Okay, so if you looked at this thing, obviously my shape is not drawn to scale. So try to forgive me on that one because 13-yard line right here is definitely less than the 4-yard line right there. And yet this is the bigger line. It doesn't matter. This is just Mr. Armstrong's mad, wonderful mind working with pictures. But when you started to find the perimeter of this shape, hopefully you notice that you're missing some items. And you got to figure out what those items are. Because not everything in life is always a nice, neat shape. Okay? So sometimes, and this is a very important point, especially when you get into 10.4 and 10.5, sometimes you might need to break those shapes into smaller shapes that you know. For instance, we are missing this side right here. Okay? We don't know what it is. But we do know that this side length down here is 13. And we know that the full side length down below is 17. So whatever happens between this length and this length right there, it must total up to that 17 down below. So now you know how to find that missing piece. Because all the way across here has to be 17. If I kind of like drew out the rest of my little box right here, all the way across here, with this guy included, has to be 17. Okay? It has to be. Because my shape is, these are all 90-degree angles. So, how much am I missing up there? Well, if you take 17 minus 13, you find out that this guy right here is 4 yards. Okay? And then last but not least, you're also missing this guy that's right here. Well, you have enough information to figure that out. Because if you look directly across from it, notice you got this little piece right here, and you got this little piece right here. And if I connected those two, they would make the full length across there. So how much is my longest side right over here? Well, I need to take the 4 yards and the 13 yards and put them together. And that's 17 yards. So sometimes you have to use information in your picture to help you find some of those missing pieces. Because they're not going to be nice and obviously give you all the numbers that you need to know. So now, if we walk the perimeter of this shape, we will actually find the perimeter. So let's talk about that. So let's say I start here on my perimeter check. How far did I go? 13. Plus, how far did I go? 13. How far did I go? Plus 4. How far did I go? Plus 4. How far did I go? Plus 17. We grab this guy, move it down below a little bit. Grab all this, kind of shift it up some so I have a little bit more room. And then last but not least, walking the rest of my perimeter. Now I'm back at headquarters. How far did I go? 17. So add all those numbers up, and you now get the perimeter of your shape, which would be 13 and 17, that gives you 30. 13 and 17, that gives you 30. 30 plus 30 is 60, plus another 8 in the middle, so 68 yards. All perimeter answers are just the label: yards, feet, inches. If there is no label, call it units. If there is no label, it is called units, but it is just a plain, simple label: yards, feet, miles, meters, centimeters. Nothing special about it. Again, all perimeter is adding up all the way around your shape. Sometimes you might need to find some missing values, and that's okay. Use your shape to help you out with that. So I believe this is the last example. Let me double check. Yep. So in here, it says that a school playground is in the shape of a rectangle, 800 feet long and 100 feet wide. Okay? If fencing costs $12 per yard, what will it cost to place a fence around the playground? So in geometry, I already mentioned this in 10.1. Draw yourself a picture. You have a rectangle that is 800 feet long and 100 feet wide. I usually let the length be down at the bottom and the width be on the side. But it doesn't really matter. You know, length and width are kind of interchangeable. Okay? So in this problem, it's a 3-step process. Okay? And you're going to see problems like this in area and also in volume. Okay? It is a 3-step process. And this process is very straightforward. So that's what our picture looks like. Oh, look down here. I got something covered up. Let's find out what it is, because I forgot it was here. There's the process. So the first thing you're going to do is you're going to want to find the perimeter, the area, or the volume. That's the first thing you're going to want to do. So since we're in 10.3, it's all about perimeter. When you're in 10.4, you'll find the area. When you're in 10.5, you'll do the volume. Okay? So find that information first, the perimeter, the area, or the volume. So let's do step 1 real quick. So we got our figure here. It's a rectangle. So if I start here at headquarters and I start heading out, I went up. How much is that? Well, remember about those little things that we talked about at the beginning of this. What do we know about opposite sides of a rectangle? Because it is a parallelogram, they're congruent. So since this guy over here is 100 feet, this one is 100 feet. So my perimeter so far, I've walked 100. Plus, how far did I walk? Again, using that same property we just talked about. We know that opposite sides of a rectangle are congruent. So since this guy down here is 800, up here, the top length is 800. So I walked another 800 feet. Plus, how far did I walk? 100. Plus, how far did I walk to get back to base? Another 800. So if I add all this up, 100 plus 800 plus 100 plus 800, that ends up being 1,800 feet. So that's the perimeter of our shape. But if you look up here, and this is going to lead us to our next step, notice that the fencing is all about the price per yard. The price per yard. So that's what step 2 is about down here. We need to convert, because right now we're in feet. I need the answer in yards. Okay? So that's why we learned 9.1, 9.2, and 9.3, because we're going to take this 1,000, just jump back down. We're going to take this 1,800 feet, and we're going to turn it into yards. So again, we need to find that unit of measure or unit fraction that we can use. And if you go back to those notes, this is where it's not going to give you the conversions you want. So if you go back to your notes, that conversion sheet that I had at the beginning that you could print out, this is where you definitely want to use that information. So we know that 3 feet equals 1 yard. So the guy that we want, yards, goes on top. The guy that we don't want, feet, goes on bottom. And according to what we know, the 3 goes with feet, and the 1 goes with the yards. So now you know how to multiply. We're going to take 1,800 and multiply that by 1/3. Again, if you're not good at fractions, just go to your calculator. 1,800 times alpha, y equals 1/3. Enter. So there's how many yards my fence will be. 600 yards. Actually, I want that in green because this is the step 2. So we've converted it, and now you can find the price because that's the last step. Now that you have it in the correct measure, now we can find that final answer. We can find the price because all you need to do is take the price that we know up here and multiply it by the yards. That's how you find that final answer. So how much will it cost us to fence in the playground? We're going to take 600 times 12 because it costs us $12 per yard, and we have 600 of them. So go down to our calculator. 12 times 600 equals, there's the price to fence in the playground. It will cost us $7,200. And you will have problems in area and volume that are just like this. So you'll find out the perimeter area and volume first. Then you will convert. And then you will find the price because you will be in the final correct format. And that's 10-3. That's it. Happy assignmenting.